Hello, students who are taking Math for Business and Finance or Math Applications. This is for Chapter 5, Solving Equations for the Unknown. Actually, this here is Part 2, so let me, we did one before, and let me just make this a little bit clearer here by putting in a dot 2 there. Okay, I didn't do that for number 1. All right. So in the previous video, we had covered the variables and constant rule. Okay, go back and watch that video. And also, half of it was an explanation of the series, so I'm not going to cover that again. We covered the variables and constant rule, so I'm going to move on to solving for the unknown rule. Okay. What this says is whatever you do to one side of an equation, you must do to another. Okay, so what does that mean? Well, let's say I have 4 plus x is equal to, I don't know, I'm going to just pick a number here, 36. Okay, it doesn't matter, all right. We're just talking about solving for the unknown rule. Whatever you do to one side of an equation, you must do to the other. Well, the equation is represented by the equal sign. So whatever I do to this side of the equation, I have to do to this side. Well, let's say, for example, I decide that I want to multiply this 36 by 2. Okay, so I have to multiply the left-hand side by 2, and I have to multiply the right-hand side by 2. All right, so this would be come out to be 8 plus 2x is equal to 72, and then I would go on to solve for the x. Okay, and that's jumping ahead, but I just want you to realize that for this rule, whatever you do to one side of the equation, you must do to the other. So if I decide to add, and I'm going to just change this here a little bit, I just multiply by 2. Well, what if I decide to add 10 to both sides? All right, well then 10 plus, so I'm adding the 10. Okay, I just added 10 to both sides. And the reason why that works is because this is an equal sign. Okay, this is saying that this is the same as this. So if you change this side by a certain amount, you change it by this, you have to change the other side by that same amount. You can't just add 10 to one side. All right, you have to do both sides of the equation. The equal sign represents the equation, a left-hand side and a right-hand side. Okay. Now remember, the rules that you had in the last video, the rules in this video or the next video, these are theories and ideas and hypotheses, or whatever you want to call it, that you don't need to memorize, but you do need to understand. And even though I'm working in isolation right now with this particular rule, when it comes to doing a word problem or solving for something, I have to know these rules intuitively to use the right one at the right time in order to arrive at the right answer. Okay, so it feels like I'm working in a vacuum here, but for the moment, that's what it needs to be, because everything gels together when you're solving for the word problem. Right. Next rule, the opposite process rule. Let's see here. If an equation indicates a process such as addition, subtraction, multiplication, or division, solve for the unknown or variable by using the opposite process. For example, if the equation process is addition, solve for the unknown by using subtraction. Okay. All right, what does this kind of mean? Let's see here. All right, let's say we have 3 plus x, x being a variable or the unknown. And the textbook likes to use the word unknown. And it means the same thing as the variable. I don't use the word unknown as much. I always use a variable. It's easier to say x is a variable than to say x is the unknown. All right. So just be aware that when you're talking, the book does talk about unknowns and variables almost interchangeably. And so if I have 3 plus x and that's equal to, say, 5, right? So this is an equation. If an equation indicates a process such as addition, which it is, it's adding 3 plus something equal to 5, then we solve for the variable or the unknown by using the opposite process. Okay, so what does that mean? Well, I'm going to isolate the x on the one side of the equation. So since I have a plus 3 here, I have to, on this hand side, well, if I subtract a minus 3, right, plus x, now notice that I made it a minus 3. I'm going to add the minus 3. Oops, I should have wrote that a little different. Let's back up here a second. See, my mind has already just jumped so far ahead, right? So I have a plus 3 plus x. And if I take, and remember, this is a plus, and if there's no sign in front of a number, that means it's a plus. We had gotten that from our first set of rules there. Number 2 here, no sign in front of a letter or number means it's a plus. Okay, so by having nothing in front of this here 3 right here, that means that's a plus. Now, in order to do the opposite process, I need to subtract 3. There's my opposite process. If I have an addition, I'm going to subtract. Okay. And when I do that, since I did it on the left-hand side of the equal sign, that means I also have to do the same thing on the right-hand side of the equal sign. Okay, that goes back up to the previous rule. Whatever you do on one side of the equation, you have to do on the other. So by using the opposite process here, okay, a minus 3 plus a plus 3 means I end up with 0. And so all I'm left with is just the x. And the other side of the equation is 5 minus 3. And when I do the math on the other side, it ends up being 2. So that's how 3 plus what is equal to 5. Now, we know that 3 plus 2 is equal to 5 because we solved for that variable, that unknown x. Now, in your head, you probably did that really quick, right? Just because you've had so much life experience. But this here is the process that you go through mathematically, and you need to know this process in order to work with more difficult equations. Okay, and you have to know these rules and understand the concepts in order to be able to work with more difficult equations. So even though this seems so simplistic and it's like, yeah, I know this. I mean, me personally, it's like, oh man, it's hard for me to be explaining this because, one, I just automatically did it so quickly in my head that I knew that the answer was 2 without having to think through this. But when I do get to more difficult problems, I have to work with these concepts and rules in order to arrive at the answers I need. Okay, I hope that makes sense. Okay, next slide. All right, next rule. Equation equality rule. You can add the same quantity or number to both sides of the equation and subtract the same number or quantity from both sides of the equation without affecting the equality of the equation. Right? It's saying you can add and subtract the same amount to both sides of the equation, and it doesn't change that equality. You can also multiply or divide both sides of the equation by the same quantity or number, except 0, because we can't divide by 0, without affecting the equality of the equation. So this is saying the same thing. I can multiply or divide, right, on both sides of the equation, all right, and that's not going to affect the equality of the equation. So in other words, if I multiply one side, I have to multiply the other side. If I divide by on one side, I divide on the other side. Same with the addition. I add one to one side, I add to the other. I subtract to one side, and that goes back to the solving for the unknown rule. Whatever you do on one side of the equation, you must do to the other. Okay, that's all this is talking about at this moment in time. Okay, all right, and then to check your answers, substitute your answers for the letters in the equation. The sum of the left side should equal the sum of the right side. Well, in the previous slide here, we had 3 plus x is equal to 5. And so let me just quickly rewrite this. 3 plus x is equal to 5. Now, it says here we add or subtract on both sides. So I realize that's a plus 3, and so I'm going to subtract 3. I'm going to subtract 3. Minus 3 and a plus 3 ends up being 0, so I'm left with x is equal to 5 minus 3. I subtracted by the same amount on both sides, and that means it doesn't change the equality of the equation. And now, when I solve this, I end up with x is equal to 2. So what this part now says is to check your answers, substitute the answer into the equation. So if I have 3 plus x is equal to 5, I substitute the x with whatever I found that out to be. So I take 3 plus 2 is equal to 5, and I do the math, and I end up with 5 is equal to 5. Again, very, very simple, right? But that's the basis of the rule, and when you work in the word problems and it becomes more complicated, you're going to be using this rule. No, I didn't memorize it, but I understand it. And with that said, we're going to move on to a part 3.